Right, let's have a look at this integral. We've got to show that this equals that in the first instance. The nice thing is that that's telling us that this is the difference between two squares. And you can see that because x squared minus 4 is x squared minus 2 squared. Remember the formula? A squared minus b squared. It's a standard formula. A minus b, a plus b. So this left-hand side, x squared minus 4, we can write as equal to 8 over x. And then it's going to be x minus 2 squared, wasn't it? X minus 2, x plus 2. Completing the square, that's called. That's a 2. Okay, so now we've got linear factors. We can just use the linear factor rule, can't we? So it would equal a over the first linear factor plus b over the second plus c over the third. So multiplied by the denominator then, and all these things underneath will go, and it's just like cross multiplying on the top, isn't it? On the left we'll get 8 is equal to a times these two plus b times the other two plus c times the other two. Okay, convenient values. Put x to 0 as a convenient value, isn't it? 8 is always on this side. 0 in here. We'll just get minus 2 times plus 2 is minus 4 lots of a. 0 in here and here will be 0. 8 over minus 4 is minus 2, so a equals minus 2. X equals 2 is the next good value to put in, say. This will be 0, this one will be 0, this will be 4 times 2. 4 times 2 is 8, 8b. So b is 1. 8 over 8 is 1. That's b. X equals minus 2 next is the last value we need to put in. This will be 0, and this will be 0. This will be non-zero. 8 again equals minus 2 times minus 4 is plus 8. C equals 1. So we've got an integral then. I'm going to just, to save time, I'm going to put it in here, just at the top, and save lighting a fresh line. So minus 2, b is 1, 1, and c is 1, which is what we wanted to show. So our integral then is equal to minus 2 over x plus 1 over x minus 2 plus 1 over x plus 2 dx. That's our integral. We need to work it out between 3 and 4, don't we, as we're asked. So that's equal to minus 2 ln x. The integral of 1 over x is ln x. The integral of this is ln x minus 2. The a value is 1. 1 over 1 is 1. Plus the same again pertains for this one as well. Between 4 and 3. So what do we get? Put 4 in. Top value, take bottom value. Put 4 in. Minus 2 log 4. Plus 4 minus 2 is 2, so that's ln 2. And then put here plus ln 6. And then put 3 in, minus 2 log 3. And then 3 in here will be 1, which will be 0. And then 3 in here, ln 5. So we've got minus 2 log 4, which I can use properties of logs and write as log of 4 to the minus 2, plus ln 2 plus ln 6, minus, and run the minus all the way through the bracket. So that becomes plus ln, and the 2 can go up to be 3 squared, because I've taken the minus, care of the minus with this, and then the minus log 5. So what have we got? We've got plus u times and minus u divides. So we've got ln 4 to the minus 2 times 2, because plus u times in logs, times 6 times 3 squared, which is 9, and minus u divides, so that would be all over 5, wouldn't it? And this is equal to ln 4 to the minus 2 is over 16, so I'm going to put the 16 underneath, times 6 times 9 over 16 times 5, and see what we get. 16, 8, and that goes 3, and that goes to 4. So we're left with ln 3 9s are 27 over 4 5s are 20, which is what we wanted to show. And we can show on the calculator what it equals as a decimal. Natural log of 27 over 20